I often hear the geological evidence that supports the idea that the Earth is billions of years old and that the layers of sediment that we find on the Earth are millions of years old. But is there any evidence from geology that the Earth is younger, that the sediments are thousands of years old, not millions? Yes, there is, and that's what I'm going to be presenting in this video. Now, my source is Dr. Monte Fleming, who has a PhD in geology. And if there's any geologist that wants to respond, I'd be happy to have you on this channel to discuss your responses to what I'm presenting as evidence that the Earth is much younger than what is commonly supposed right now. So the first evidence from geology that I want to present is the issues related to erosion. Now, in the United States, the Pacific coast erodes at an average of about 8 inches per year, and the Atlantic coast erodes at a rate of about 31 inches per year on average. Now, at that rate, those coasts would meet after 4.2 million years of erosion. Now, the North American tectonic plate was, and the general shape of the continent as it is now is supposed to have been here for 200 to 300 million years. So why hasn't it completely eroded? You know, it would have to like completely stop eroding for the majority of that time period in order to preserve the continent that we have today. And so in the span of its history, it should have eroded completely many times over. Why do we even have a continent? And then why can't we see a history of millions of years of erosion? You know, when you look at from above and you see a photograph of the coastline, you can see how there's a lighter line around the coastline, and that is like comprised of sediments that have eroded, but we don't have evidence of millions of years of sediments eroding there. So this is a big problem for the idea of the layers in our continents being 200 to 300 million years old. Another problem for the model of geology that requires millions of years is the problem of mountain ranges. Mountain ranges are uplifting and they're also eroding. Now, one of the most studied mountains is probably the most studied mountain is Mount Everest. And so Mount Everest, there's been studies about its uplift, that it's uplifting a very, very conservative rate is to say it's uplifting at a rate of 4 millimeters per year. So at that rate of uplift, then right now Mount Everest should be about 52 miles tall. Okay, and that's keeping in mind an erosion rate of 2 millimeters. So with 4 millimeter uplift, which is very conservative, there's been studies that have shown much higher uplift rates, but very conservative rate of 4 millimeters per year and 2 millimeters of erosion per year, then Mount Everest should be 52 miles tall. Why isn't it? And the other problem related to Mount Everest is with the erosion, because with the erosion rates, the layers at the top of Mount Everest should have been gone a long time ago. Right now, at the top of Mount Everest, we have limestone layers with marine fossils, and those are supposed to have came from the sea floor where the mountain originally uplifted. Now, at the most conservative erosion rates, all of those limestone layers at the top of Mount Everest should be completely have eroded long ago. So why haven't those layers eroded in all that time. And so there's no explanation for that. Now, the other issue we have is the issue of deposits. A lot of these sedimentary layers around the world, there's layers of massive, massive sediment formations around the world. And we're being told that a lot of these formations, that each layer corresponds to millions of years of Earth's history. But that doesn't really fit with what we see inside the formations. For example, one example of many is the Pisco Formation in Peru. Now, this layer of sediments is supposed to be 13 million years worth of layers. But in that layer of sediment, you've got complete whale fossils, dolphin fossils, shark fossils, huge animals. And fossilization is not what normally happens when you've got, just an animal that dies. It has to actually be buried very rapidly in order to fossilize. Otherwise, it just decomposes. It can't be exposed to the air. It can't be exposed to the different types of animals that would feed off of it. It has to be buried very rapidly and not exposed to the elements in order to fossilize. So you've got these gigantic animals that have been fossilized in layers, this layer that's supposed to represent 13 million years of Earth's history. So that's only a sedimentation rate of about an inch every 200 years. So at that rate, how would these animals have been buried and fossilized if that sedimentation layer was laid down slowly over 13 million years? And there's many examples like that all over Earth. You have the Morrison Formation in the United States with so many dinosaurs in it. And that's the other thing, is these huge formations of sediments that we actually don't see that kind of process happening on Earth today. The largest formation that we see happening on Earth, the largest formation of sediments, is with the Ganges Delta. And I want to look at that deposit is 39,000 square miles big. Now, the older layers of the geologic column are much larger than that. For example, the Coconino Sandstone in the Grand Canyon is 927,000 square miles across. Now, that's supposedly, according to the geologic model that is often presented, it's supposed to have formed in desert conditions over millions of years. But we've never seen wind make any type of large formation like that. And many of those layers that are in the Grand Canyon that are supposed to be separated by millions of years, there's no signs of erosion between those layers. Normally you would have, animals burrowing, you'd have plants growing, you would have certain areas that are eroded, but a lot of those layers in the Grand Canyon and other places are just one layer and then another layer right on top of it with no sign of erosion in between. So the stories that we're being told about how these layers form don't really match up with our observations. And the last piece of evidence that I want to talk about today is the fact that the world's rivers deposit about 15 billion tons of the Earth's crust into the oceans annually. Now, at that rate, all of the land on Earth would erode to sea level in 22 million years. So why hasn't all the land eroded? Now, for those who would say, well, we constantly have new land uplifting from the mantle, well, that doesn't really explain it, because why do we still have all these fossil bearing layers? Those should have been gone a long time ago. So these are some of the problems related to the geology model that says that all these layers on Earth are millions of years old, and that the Earth itself is billions of years old. So I'd love to hear any responses to that from people who have expertise in this area. Thanks for your time, and hope you have a great day.